This is the problem number 34. This problem states that a harmonic oscillator is in a state such that measurement of energy would yield either half h cross omega. Let the energy is represented by E naught is equal to half h cross omega, or 3 by h cross omega. Let's represent this E1, that is 3 by half h cross omega, with equal probability. That means the probability of this E naught getting E naught and the probability of getting E1 is equal. That is 50-50%. That is half. What is the largest value of the P? We have to find out this value, that is maximum. And if it assumes the maximum value at t is equal to 0, and then we have to find out the what is the psi xt. So let us assume the such state is represented by some uh, wave function, that is psi xt. Let psi xt is equal to c naught psi naught x, only position dependent, and the energy e power minus I E0 and T by H bar, with the energy E naught plus C1 psi 1 x e power minus I E1 T by H bar. So this is the wave function, and here the probability of getting E naught is a half, and probability of getting E1 is also a half. So from here, if we find the probability of finding the E naught, then probability of E naught is nothing. It is the coefficient of the C naught square, and this is half. And similarly, the probability of getting E1 is equal to the this C1 square, and which is also half. So let us find out this value, that is C naught is equal to 1 by root 2, and let's define this probability depend on some phase, that is e power I theta naught, and this probability, that constant, that is c1, depends upon, that is 1 upon square root, then c1 is equal to 1 upon square root, and this, let's assume this depend on the theta 1. So this is the equation number 2, and here theta and theta naught are some real values. Here theta naught and theta 1 are real constant. Now we have to find out the maximal value of the P, that is we have to find out this first, and then we will find where this expectation of the P is maximum. So the formula for this is psi xt, and the P psi xt. If you find this one, that is find the complex conjugate of this one, the c naught psi naught e power plus I naught t h bar, and here is this c1 star C1, and then we multiply to each other, then we will get C naught square, and here this part will cancel, that is e power I naught t y h bar, and there another part will be plus, this will cancel out, then we will get only psi naught and the psi naught or psi naught. So here we will get psi naught x, we will psi naught x and p psi naught plus c1 square psi 1 and p psi 1 plus c naught complex conjugate and the c1 e power I. If you find the complex conjugate of this, then I, this part will be positive from here. This e power plus I e naught t by h bar, and another part will be negative. So this will be e naught minus e1 and t by h bar, and this will be psi naught uh, p psi 1. This is the only position dependent, plus C1 complex conjugate C naught e power I. This time E1 will be positive and E naught will be negative. E1 minus E naught T by H bar, and this will be psi 1 and P psi 0. So this is psi 0, psi 1, P psi 1 is psi 0, and P psi 1, psi 1, P psi 0. Now, now we have to find out this value from this data, that is E1 minus E0, that is E1 is 3 by 2 h cross omega, and this is half h cross omega, that is this is h cross omega, that is E1 minus E naught by h bar is omega, and this relation psi naught and p psi naught is equal to 0, and psi 1 p psi 1, these are also 0, and this result is from the problem number 2.1, sorry 11. Now, so we have this value is we have, and this value we have. Now we don't have this value psi naught p psi 1 and psi 1 p psi naught. Let's find out these two values. So psi naught p psi 1 is equal to I m h bar omega by 2. This is the value of the p, and psi naught, and the value of the p is a dagger minus a, and this is p psi 1. Now operate this a dagger on the psi 1, a psi 1, then you will get I m h bar omega by 2. This value will be psi naught A dagger psi 1 minus psi naught A psi 1 I am h bar omega by 2. This value will be, that is A dagger will increase, that means it will 2 and psi naught, and this will be psi 2 minus, so this will down this one state, that is it becomes 0, so it is 1 and psi naught, and this is also psi naught. Hence this value is delta 0, delta 0 2, and this value will be 0. This is delta 0 0, this is 1, hence this value, this becomes 0 and this is 1, hence this value is, that is psi naught p psi 1 is equal to minus I m h bar omega by 2. Similarly, we can find this psi 1 p psi 0 is I m h bar omega by 2 psi 1, and this is A dagger psi 0 minus psi 1 A psi 0. This is m h bar omega by 2. This value will be, that is, it will increase one state, it is 1, and this is psi 1 and psi 1 minus this value will be 0, because this state become, that is this is square root of 0, and this, let's write full solution. This is 0 and psi 1 and psi 0, so hence this become 0. So the value of this psi 1 p psi 0 is I m h bar omega by 2. Thus now substitute all these value, this value, and here is all value in this p. Expectation p is equal to the first two part are 0. You can see this, this part is, can say this is 0, because this is 0 and this also 0. Then we get only two values, so c naught c1 and this value. This these are two values are, that is 1 upon root 2 e power minus I theta naught c naught star 1 upon root 2 e power I theta 1 and e power minus I omega t, and the value of this minus I m h bar omega by 2 plus 1 upon root 2 e power minus I theta 1 upon root 2 e power I theta 0 and e power plus I omega t, and this value is I m h bar omega by 2. Let's take common term here. This 1 upon root 2, 1 upon root 2, that is 1 upon 2, and I by 2 mh bar omega by 2, and here this is minus e power minus I omega t, and this is also minus, and this is minus minus theta 1 minus theta 1 plus theta naught plus e power, this is plus I omega t minus theta 1 plus theta naught, and this can be written as the 2I, because this is e power I theta minus e power minus I theta. This will be 2I, so this is, and I is present here, and if I write this, let's write mh omega by 2 into I by 2 into 2I sine omega t plus theta naught minus theta 1, and this I here, okay, this is 2I, and now 2 cancel, it will be minus. So this P is minus mh bar omega by 2 sine omega t plus theta naught minus theta 1. This is the expectation of the P. Now in the question, if it is assume the maximum value of the t is equal to 0, so if this P has maximum value at t is equal to 0, and this maximum value is m h bar omega by 2, then substitute t is equal to 0, then this value must be minus 1, that is sine theta naught minus theta 1 must be minus 1, and this value will be sine minus pi by 2, or theta naught minus theta 1 is equal to minus pi by 2, or theta 1 is equal to theta naught plus pi by 2. So at this value of theta 1, the and t is equal to 0, this momentum expectation value will be maximum. If I assume theta naught is equal to 0, then theta 1 is equal to pi by 2. So at these two conditions, that is at theta naught is equal to 0 and theta 1 is equal to pi by 2 and t is equal to 0, the expectation of the momentum will be maximum in such state, and the state are defined, that is psi xt is equal to, we have assumed that is c naught psi naught x and e power minus I e naught t by h bar plus c1 psi 1 e power minus I e1 t by h bar, and we have already find out the c naught, and from here c naught is 1 upon root 2 e power I theta naught, and theta naught is equal to 0, that means it is 1 upon root 2, and this is 1, and c1 is equal to 1 upon root 2 e power I theta 1, and this is 1 upon root 2, and here theta 1 is equal to pi by 2 e power I pi by 2, and e pi by 2 is equal to cos pi by 2 plus I sin pi by 2, that is, this is I upon root 2, and now substitute the value of this e naught e1, then you get the state, and which is given as psi xt is equal to 1 upon root 2 psi naught x e power minus I omega t by 2 plus psi 1 x e power, that is e power, this value c1, uh, this value is I upon root 2, oh sorry, and e power minus the value of the e1, that is 3I omega t by 2, and if I take I omega t, and this, oh, one term is missing here, oh this is here, so we will not write this because this is already common, and now 1 upon root 2 e power minus I omega t by 2 is psi naught x plus I psi 1 x e power minus I omega t, and that is minus I omega t is common here, so it will be minus I omega t, because this I omega t and I omega t, if you add, then you will get 3 I omega t by 2. So this is the such state in which the expectation value of the momentum is maximum, and the probability of getting E naught and E1 is 50%. Thank you.